I am going to speak today about Fury, which is essentially a build tool I've been working on for Scala for the last year or so. How many people here are familiar with Fury? A few, not many. SPT? Okay, everybody. So you're coming from the point of view of understanding SPT. You've probably had some good experiences with it, maybe some bad experiences as well. And what I want to do is develop a new build tool with a clean sheet of paper that gives you an entirely good experience. It is a build tool. I think I might make this a little bit bigger. Can you read that? It's also very much a dependency manager. So I'm focusing as well on what is largely an orthogonal task of resolving dependencies between different projects, but is very frequently lumped together into the same tool as the one which does the building. And Fury is no different, but it takes, I think most of the interesting stuff in Fury is in its dependency management rather than its building. So I don't follow any established conventions. I try to avoid just adopting the same thing that people always did before. And one example of that is that I define the builds in terms of static data. I have an algebraic data type which represents a model for the build. I don't have code which needs to be run and compiled in order just to work out what the build does. It's built on source dependencies rather than binaries, so you're probably familiar more with binaries published on Maven Central. Fury uses source dependencies generally published on GitHub or other Git services. And there's no build file. You're not editing a build file with a text editor. What you do is you run commands which change or mutate that build. So the user experience is different. It's command line based, or primarily command line based. We can provide other APIs later, but it's focusing on the user experience in a similar way to how Git does than maybe other tools like Gradle or SBT, which use a file that you edit and usually commit into Git. The builds themselves are stored as hashes, and I'll talk a little bit about that later. That's a new feature which I implemented in the last week or so and is working very well so far. Why am I doing this? Well, I find that, in particular with SBT, it's not easy to look at a build and to know immediately what it does. They're quite opaque. You may have a build that's 1,000 lines of code long, and you can visually pattern match on certain parts of that build to see things you recognize as being task definitions, but it's quite challenging. It's non-trivial, and in order to know absolutely what the build does, you would actually have to read the code very carefully. That's not something I want to repeat. Maintaining builds is generally quite difficult, and this is also one reason why the Scala ecosystem generally moves quite slowly. Publishing is slow. You have to wait for all of your dependencies to be published, or the updated versions of those dependencies to be published, before you can publish your newer version. That's one of several reasons why it takes maybe months, and in the case of Spark, years, to get a new version published for the latest version of Scala. I want it to be minutes rather than months. And basically releasing and sharing libraries, releasing to Maven Central, the process, the first time is nearly impossible. I mean, it's a useful barrier because it means that you have to really want to publish something in order to get it onto Sonatype. But it's a lot of work. It fails sometimes. It's unreliable, and it can take up to a day for the bit between pressing the button to publish and actually seeing the new library available. Additionally, compiling Scala is slow. That's something which I'm relying on Bloop, which is a build server developed at the Scala Center, to help me with. But I'm taking advantage of that where I can. So I'll elaborate a little bit on each of these. I'm going to go quite fast because I've got lots of slides. I'm using I'm using data to represent the builds, and I'm trying to encapsulate in those data files, in the model, every relevant aspect of the build. I'm trying to find an encoding for all the things you might want to include in a build and put it into a nice, manageable model. What this means is that the dependency graphs and all the details of or calculating all of the details of the build, it's not Turing complete. You don't have to compile it. You don't have to run it. You just know. You're working with data structures. They're much easier to work with. This also means they are simpler. They're faster to run, and we can analyze them very easily. And this is great for tooling. Code is difficult, slow, and can't be easily analyzed. So I think data is a better format for dealing with builds, provided we can encode everything in the build, in that model. I choose to use source dependencies. Now, there is a bit of a debate ongoing between whether source dependencies or binary dependencies work better. Maintaining source compatibility, one version of the source code that compiles with maybe different versions of the same library or different versions of the Scala compiler, is challenging. There's always risks that the compilation won't work. But if you're compiling from source, at least you get to check that. You get the compiler telling you there's a compile error. What you don't get with source dependencies is the risk of a linking error at runtime. The very best time to learn about a problem is at compile time, not runtime. We don't have to wait for someone to publish binaries in order to use them. We can just depend on the latest version of the source. We can depend on source from a pull request if we want to. It doesn't even have to be merged. Any commit hash referring to any publicly available Git repository can be used as a dependency. And this also means that anybody can publish a build. The build is independent of the repository that contains the source code. If the maintainer of the library doesn't want to continue working on it, or doesn't want to adopt Fury, which is a perfectly reasonable position, especially because it's so immature right now, someone else can go and do that. And what this means from a bootstrapping point of view, bootstrapping the ecosystem to use Fury, is that I don't need to persuade every single library author to adopt Fury. I just need to persuade a few people who want to help me convert some of those libraries to use Fury. So it uses a command line interface, very similar to Git. And you typically run commands, and these either provide you with some information about the build. They tell you what the projects are. They tell you the dependencies between them. They initiate running compilation. Or they make some mutation to the build. You add a project, you add a module, you add a dependency between them, you update a source repository to the latest commit hash. These are all mutating commands. This point here, it has colorful output. Might sound like just a nice thing to have that's not too important, but I think it's very important for understanding what's going on. So I've put a lot of attention into the user experience. I've tried to make it as understandable as possible and intuitive as possible. So there's a few concepts which I'll introduce over the next few slides, like layers, binaries, sources, repositories, projects, modules, dependencies. All of these, whenever you see them in the output from Fury, will have different colors, but you'll learn to recognize what those colors are. You'll learn that if you see something called shapeless and it's yellow, you'll know after a while that that's a schema and not shapeless the project. Shapeless the project would be blue. So it's trying to help you as much as possible to get a good understanding of what's going on. This covers all the output, including log messages. We also have tab completion. So every time you need to specify a dependency, for example, you can press tab on the command line, and it will give you a list of suggestions of things you can depend on. This is really useful for those fields, those parameters that can be selected from a list. It makes the interaction very fast. It gives you really good intuitive and interactive feedback when you're running the commands. The recent change I've made is that builds are now stored as hashes. So if we want to depend on a build, we don't need to specify what that build is. We don't need to import the entire contents. We just refer to it as a hash. If the build changes in any way, if we add a project, if we change the repository commit hash, the hash of that build will change as well. And build hashes are immutable. They are a hash of the content that the data content that describes the build. So they are permanent. If you have a hash, that always refers to the same thing. And I wrote this morning because I'm getting to the stage where I feel like Fury is closer to something I can recommend to people. It's been in development for a year. It's been useful for a few of my small projects, but we're getting closer to the point where I can actually start to suggest it to people. And what I want to do, this is maybe a mission statement. I want Scala users, Scala programmers, to have the best build tooling experience, not just compared to the other Scala build tools, but compared to other languages and ecosystems that have a need for build tooling. That's my goal, and I'm trying to be innovative, and I'm adopting a few radical different ideas in Fury to do this. So let's talk about building. This, maybe you've seen me tweet in the past. This is a video of Fury. Can you see what's going on here? Fury clean classes, and I run Fury, and then after a couple of seconds it launches Bloop, and it's giving updates on a number of modules that are compiling at the moment. Down here, we can see what the dependencies are between those. It's doing the highlighted ones in parallel, and we see progress updates for how far through compilation it's got. This is in real time, and we've got an error message there. You probably can't read this, but it says there are errors, and it actually says there's 2 errors and there's a bug in this video because there's only one. But we get a reference to the line that contains the error, and it does actually highlight the entire token, not just a pointer that points to the first character. That's indicative of the sort of visual experience I want people to have when using Fury. So let's talk about some of the concepts. One of the most fundamental ideas in Fury, which is probably new to most people, is the idea of a layer. A layer can be thought of as a workspace or a collection of projects, a collection of things you're working on at the same time. Each project, and a project is probably very similar, as I said before, to your current idea of a project, corresponds to a Git repository. It probably has a name that you would recognize, but may consist of one or more modules. And the modules, each module is one invocation of the Scala compiler. So it's one phase of compilation. If you have to compile some macros and then you compile some code which depends on those macros, because they're macros, it needs to be 2 separate compilations, but that is 2 separate modules. You define them, and then you define a dependency between them. And modules form a compilation graph. Now these are modules from any project. You can have one module depend on another module in a different project, and that project can then depend back on your original project if you wanted to. I'm not saying that's necessarily a good idea, but the compilation graph is basically Fury is orchestrating a collection, a graph of modules, each one of which is calling the compiler once in the right order, in a topologically sorted order. And layers may be published. A layer is sort of your entire build that you're working on, may be published on IPFS. Now I'm going to ask, how many people know what IPFS is? Not many, okay. So I'm not going to talk too much about IPFS, except that I will recommend you have a look at it. If you come away from this talk and think, Fury, well, maybe it's interesting, but I don't want to use it, at least go and check out IPFS, because it's a cool new open source project that Fury is using quite extensively. I'll tell you a little bit more about it when the time comes later. But I want to go through an example now. Imagine you have 3 layers. This rectangle, and this one are meant to represent layers. Within each layer, we have one or more projects. That's the green square. So Doobie has two. In this hypothetical example, has two projects, and the blue dots are modules. Now, layers can depend or can import other layers. So each layer may need to depend on projects that are defined elsewhere in different layers. If I need to depend on Shapeless, I haven't defined Shapeless within my build, but imagine if I'm Cersei, I can import the Shapeless layer into scope, and then I have available the Shapeless project, this green square here, to depend upon. I can depend upon Shapeless core, which is this blue dot here. This is what these orange arrows are meant to be dependencies. So remember, dependencies are between modules, imports are between layers. So this is typical for a typical Scala project. But the layers can be built up upon each other. So I can define a type level layer if I want to, and that type level layer can import Cersei, Spire, Doobie, Monix, and maybe a dozen other projects. And effectively, this creates an aggregate layer. Doesn't define any projects or modules itself, but it defines an aggregate layer that pulls in all of the projects that are defined up here. So that can then be republished, and anybody who depends on the type level layer gets access to all of those type level projects to depend upon. We can go further. Maybe the Scala community would want to set up the Scala community build layer, which not only contains type level modules, projects, but also contains things like Scala test. And then in my project, whatever I happen to be building that week, I can depend upon the community build, and I immediately have access to an entire universe of projects which I can depend upon. So the layers compose. We can combine them, and in combining them, we get access to a wider set of projects that we might want to use. How many people here have done some sort of cross-building for different versions of Scala or different platforms? So a few people. And I think probably all of you have used libraries which have themselves published to multiple different versions of Scala. So you're, I hope, aware at least that there is this need in the Scala ecosystem or in the community to support different targets. This might be different versions of Scala, 2.11, 2.12, 2.13. For some libraries that depend on the compiler internals, it might actually be Scala 2.12.1, 2.12.2, 2.12.3, the minor versions as well. Different backends also require different, need to be published separately. So if we're supporting JavaScript or LLVM through Scala Native, these are different artifacts being produced. And perhaps we even want to target different versions of the same library. Maybe we're targeting Shapeless 2.2 and 2.3. I think those are valid versions. Or we might want to write our library, which is more or less the same functionality, the same code, published under the same name, but we want it to work with both CATS and Scala Z. So we publish two different versions. Schemas are the attempt to support this and all different variations. And each schema is an entire copy of the layer. So remembering the layer contains projects, the projects contain modules, and it's basically a definition of the build. Each schema is a complete replica of that, but usually with some changes, some tweaks. Maybe we want to use a different commit hash from a dependency repository. Maybe we want to, or probably we want to use a different Scala compiler, so that's one thing we change in one schema. Maybe we want to include an entirely additional source directory on a module, which contains some shims for Scala 2.13, for example. These are additional methods that get imported that make things work or behave slightly differently so that it compiles with 2.13 and 2.12. These are all possibilities. So why do I have schemas? Why have I introduced a new concept? Because I'm very reluctant to introduce new concepts when existing concepts will cover this, cover my use cases. Managing completely different layers would be quite difficult. If we wanted to add a module to our project, that's probably a change that would affect Scala 2.11, 2.12, 2.13, and every other different variant we have. So I want to make that modification to all schemas in parallel. Now that's sort of a question for the tooling. It's the tool's responsibility to decide what effect the changes have. But that's exactly why schemas exist. So the tool, so Fury, can allow you to have global changes, global across all schemas, but will also allow you to introduce new variations. And because we're working with data, we're not working with code, we can query any two schemas in the same layer, and Fury will give us a diff, basically a set of lines that describe what the differences are. This is very useful for us to understand what the differences are between the schema. And maybe it says in schema 1 you're using Scala 2.12, in schema 2 you're using Scala 2.13. That's just a line entry that you get in the diff. It might say that there's an additional directory included in one that isn't included in the other. Let's go back to this diagram. This is what we saw before. This is my hypothetical model for the relationships between various layers. But there's a little bit more to the story than I showed you before. So we now have schemas mentioned here. Now, when I import from the community build, what I want is the Scala 2.12 variant of that. I'm planning on using the Scala 2.12 compiler, so I choose this schema. So I'm choosing that variant. Now that variant of the Scala 2.12 schema refers to the schema that's called latest in type level. These are all hypothetical names. We can call them anything we want, but I propose that if you name them Scala-2.12, that's a strong indication as to what the purpose of that schema is. And all of these layers would refer to the appropriate schema for that layer, all the way up to the top. But in our project down here, maybe we depend on Circe, and maybe we also depend on Doobie. Now, both of these refer to the Scala 2.12 schema of shapeless, but they refer to different versions of it. Now, I said that all builds are hashes, or we can hash the data, and we can get this. It's actually a much longer hash, but I've made it short. A hash like this, which corresponds to the exact contents of that build. So for the shapeless build, we're actually depending on two different versions. Now, maybe the difference in terms of the project up here is that one depends on shapeless 2.3 source code, and one depends on shapeless 2.2 source code. But we have a problem down here, because if we refer to shapeless, Fury doesn't have a way of knowing which version it should use. It has two possible routes to two different versions of shapeless. And when the build tool is working out the class path it needs to use, it's flattening that tree structure into a linearized list of dependencies, and one of these is going to win over the other unless we pay attention. What we want to do is we want to make sure that we have a uniquely resolved version of shapeless that we use. There's a few solutions to this. One thing that you can do now, which is a recent change, is access the shapeless layer via Circe and modify it to be the same layer as this one here. We can make that change directly from the command line with Fury. Maybe we need to do something more complicated, because maybe there are fundamental differences in shapeless 2.2 and shapeless 2.3. Maybe we can change the source code in Circe to depend on a different version of shapeless. Maybe we can do the same with Doobie. Maybe we need to do something much more advanced and shade shapeless. If shapeless isn't needed down here, or if this version of shapeless doesn't need to be used outside of this Circe project here, we could package shade it, so we sort of hide it behind an additional package name, and it becomes a completely separate package on the class path, so is independent of this one. But if you actually want interop between shapeless stuff in here and shapeless stuff in here, that's not a suitable solution. But this is the fundamental problem we have when working in an ecosystem that is continuously evolving. This is the crux of dependency management. There's no easy solution or no silver bullet to making this work. But what Fury does is it gives you the tools, it gives you the facilities, and makes it very easy for you to make those changes that you need to. What you can do is you can define a new version of shapeless down here. Maybe you can copy one, put it there, and that will be the one that gets used instead of this one here. There are a variety of different solutions, and that's something which I think will evolve later in Fury's existence when we have more users and more people are experimenting with it. Let's recap the model. Layers, these are the units of distribution. This is a workspace. We distribute it as a hash. Projects are the units of resolution. Now, in that previous diagram, in order to start a build, I need a one-to-one mapping from a project name to a project definition. That is why projects exist as a separate type of entity to modules. I need that definition to be identical for the whole project. Modules are the units of compilation. We can't go to get any finer grained than that. Modules fall into several categories. Most of them are libraries, so by default a new module is a library, but it might be an application. That's a module that gets compiled and then gets run as well. It runs the main method. That allows us to do things like source code generation if we wanted to. First we compile the code that will generate the source, then we run that, and we get some new sources, and then those sources would be used in a later module that will compile them. We have support for plugins. These are compiler plugins. If you depend on a compiler plugin, that gets added to the compiler when it runs. And you can even define completely new compilers which operate on sources and produce classes. Other concepts I've vaguely mentioned but won't go into too much detail on: dependencies, binaries, repos, so we track Git repositories. We check out sources from those repositories. And then there's a few other little items like parameters, compiler parameters, environment variables that are relevant when you run an application, and permissions. I don't want anybody's build just accessing files on your hard disk, so it runs in a sandbox, and you have to explicitly grant permissions in order for it to run and do those things. Distribution, I consider three different things we might want to distribute in the process of doing a build. Sharing builds, that means those definitions, those specifications of projects and modules can be shared. And I already said they're shared through IPFS and they're available as a hash. Compilations, if we've actually built if we've got a binary that corresponds to an exact specification for that module, that can be shared potentially. It's not done yet. That could potentially be shared to save us the trouble of rebuilding it. And then there's publishing binaries, the old-fashioned way, sending them up to Maven Central. So all builds, whenever you define one, whenever you make changes to it, get stored on IPFS. IPFS stands for the Interplanetary File System. It's ambitious. It intends to build a universal network of computers that allow you to address any content by its hash. Builds, therefore, stored in IPFS are stored forever. And if you run an IPFS server on your machine as well, which is just a matter of running IPFS daemon, then that build becomes instantly available to anybody else in the world who is connected to IPFS. It's accessible over HTTP gateways. So if I modify my build, and I happen to be running IPFS daemon, that will connect to nodes on the internet close to me, and all I have to do is make a change and share the hash of that build with somebody else, and they can immediately, almost instantaneously access my build and run it, and hopefully get the same results. So just a brief overview of IPFS. I do recommend checking it out because it's very interesting as a project. It's a fast peer-to-peer network. It's fundamentally distributed. There's no central repository. If Sonatype went out of business tomorrow, I'm not sure what would happen, but there is no single point of failure in IPFS. It is adaptively resilient, so if nodes come and go, it doesn't really matter. Data is stored in multiple locations, and it's immutable. The hash always corresponds to the same content. So we've defined these builds, which depend on other layers, which depend on layers, and we have access to all of them, just as a data structure. I notice that we actually have access to an entire tree that will build everything from source, from the very beginning. And that's useful. Imagine we had these layers. So we're working on our workspace. This is what I'm going to call the current layer. That layer has a hash. And that one is importing the layer identified by this hash, which happens to be the type level layer, or a particular variant of the type level layer. That one imports, amongst other things, this hash, which is Circe. Circe imports shapeless. Given this hash, and the hashes are actually much longer, but given one of these hashes, I can just request that entire build from IPFS. Fury hides this from you largely. You don't have to worry about this detail. But I can run a command like fury layer select, and I can specify a layer. So I want to access the shapeless layer, which is inside type level, or is accessible through type level, through Circe, and then we get to shapeless. And what that's doing, that is changing our current context. So from the user's point of view, you are working on your own layer, you are adding projects, modules, updating them, changing the type, adding sources, adding repositories, and then you change layer. You change layer to this shapeless layer within your project. So this arrow is now pointing at shapeless, and this is our current hash. Now we could make changes here. But I thought I had another slide on this. We could make changes here. Any change we make here will modify this hash. It's a hash of the content changes, the hash changes. Which means that this import will change, and Circe will change as well. This import will change, type level will change, this import will change, and our workspace will change. That happens entirely transparently. So you can just change your layer, make whatever changes you want to do to shapeless. You can maybe fix a bug that you found, and then you can go back to your layer here, and then you can see if that fixes whatever problems you are having with your projects and modules. You don't have to publish anything explicitly. It's automatically on IPFS. The equivalent situation with the sort of Maven, SBT, Ivy model is that you would have to check out the shapeless repository, you would make some changes there, you would publish them locally, you would then go to Circe, you would make some changes to Circe to depend on that local snapshot, you would update that, republish Circe locally. Type level doesn't have any projects, so that step is maybe not so relevant. And then in your project, you would change your reference to Circe, your import of Circe, to point to the version that's locally published. It's many more steps. And if you're iterating fast, or if you want to iterate fast, if you want to try something, see if it works, maybe it didn't, try again, you don't want to have to go through all those publishing steps. It's very frustrating for the people who do this and have deep trees of dependencies. If we want to make that layer available to somebody else, we just run this command, Fury layer share, and it tells us what the hash is. We can tweet that. I tweeted that exact hash a few days ago. Nobody knew what it was. Then, this doesn't go much further off the screen. If somebody else wants to use that, they can ask to clone it. They can clone it based on this hash here. Or, if they don't want to clone it, they don't want to access that layer directly, they just want to import it into their existing project, they can do that, but they need to give it a name. So there's no publishing step, it's instantly available. The layer refers to commit hashes that are publicly available in Git repositories. These are, this is everything another user needs to run that build. This hash is not particularly memorable, I think you would agree. I'm working at the moment on a naming layer that means we can publish to a name, some namespace that's memorable. So if you wanted to publish shapeless, maybe you would publish to shapeless slash 2.3 or something like that, and we would be able to clone that, and we'd be able to import that. Sharing compilations, so builds that have already completed. This is work in progress, or not even yet in progress, but it's in the design phase. If our builds are repeatable, and it's a desirable thing for them to be repeatable, we actually don't need to repeat them. We can use a previously compiled binary for that exact build. This is somewhat different from using the builds on Maven Central, because there would be many more different variants compiled with different versions of Scala and all the different things that might vary. But if we have a binary corresponding to a hash of the build spec, the specification for that build, we can just download that, and it's going to be faster than compilation. If it exists, we don't need to build it. But we could actually go one step further. If we're working in an organization and we've got lots of people working on the same projects, there's going to be a high cache hit rate for accessing builds that people have already done in the same company. So we could, when we try and run our build, we could actually make use of other computers on the network that are within the swarm. This is all speculative, I should say. This isn't in Fury yet. But we can aggressively dispatch work to other machines, and they will tell us, or they will tell Fury, when that's being completed, and we don't have to be running dozens or maybe even just 3 or 4 concurrent builds on our laptops. We can have different machines running those faster across the network and caching them for when they're needed. So for very large builds, for companies that are working on large code bases, this means work can be dispatched across the network and done faster, potentially. And then releasing. Releasing is something which is within about a week of being integrated into Fury. I've had some help with this from Virtus Lab, and I'll say a little bit about them later. Publishing to Maven Central with SBT and Maven is notoriously difficult. I struggled for about a year trying to get one project published, and did eventually succeed, but it was hard work. And I'm doing some work at the moment to adapt the Fury model to support definitions for releases. Definitions for releases are somewhat different from modules and projects, but I'm working out what are the details we need to provide to make a release. For example, the author, the license. These are things that we should capture, and Fury will capture that information, and you'll be able to run a command like this. I want to release version 090 of my build, and it will know what releases it needs to make for which different schemas, and it will do them all at once. You won't have to change to multiple different release targets. IDE support. How many people came to Justin's talk before lunch? So Justin talked a little bit about support in IntelliJ for BSP. There's no support in IntelliJ for Fury because he only needs to support BSP, and Fury will interact through BSP with IntelliJ. IDEs are an area I don't really work with. I've been using Vim for the last forever, and I'm slowly. It was a New Year's resolution of mine to try out an IDE, but maybe it'll happen before the end of the year. So we implement a few functions in Fury that give over BSP the information that it needs. Justin has gone and implemented these in Fury. And it integrates automatically with IntelliJ, with metals on VS Code, and other BSP clients. And it's all sort of for free. We get support for potentially many different IDEs. A point to note is Fury is also a BSP client as well as being a BSP server because it uses Bloop to do the actual compilation work. But they have different models. As far as the user is concerned, it's transparent. One of the things people like a lot about SBT is the plugin architecture, or the plugins. These provide lots of different features and facilities, some of which very much belong as part of a build. Others seem, from my point of view, a little bit unrelated to the build. They could be run by separate tools. So there's a question as to how Fury will support plugins. People have all this existing functionality they expect from a build tool, and I don't want to disappoint people too much. So how will Fury support plugins? It won't. And this was a very conscious decision I made. When you have a plugin architecture, that architecture or that interface needs to give access to the plugin to all sorts of internal details of the build tool. That's a lot of stuff I can't easily modify after I expose that API. It effectively means that I'm constrained in the amount I can innovate and change Fury by everybody who might have written a plugin at any point that people depend on. I depend, even though they're depending on me, I'm actually depending on their code because I need to maintain it in order to not break the entire plugin ecosystem. So I don't want to have a plugin architecture, but I do still want to provide the same facilities that plugins provide. So Fury will natively support a number of different things that are currently provided through plugins. That means that my plugin architecture is maybe you open a pull request against Fury if you want to provide some additional functionality. And this is sort of the Linux kernel model versus the Windows NT microkernel model. This is Linux. Everything you want to include is built into the tool. There's also the option to depend on things as libraries. So I think, although we don't have a plugin architecture, the existing functionality, the definitions of modules, the ability to do things like source code generation with modules, and the ability to write any code we like to be run during the build, as long as we have permission to do it, gives us a lot of flexibility that we can actually implement most of the existing plugins. Just some examples I found that people are using. If you wanted to use something like wart remover, that doesn't need to be a plugin to the build tool. That is simply a definition for a compiler plugin. You put it in a layer, you import the layer, you depend on wart remover, it runs. Native packager. This, I think, does all sorts of fancy things like building Docker containers. I don't need that to be part of my build tool. My build tool will give you a jar file. There's some customization you can do to the jar file, but it'll give you a jar file. You can do what you like afterwards. You can write a make file that runs Fury and then runs some sort of packaging. That would be my preferred solution. That is not part of the problem space that I want to go into, at least not yet. Scala format is sort of the opposite end. It's source code. You run Scala format before you run the build. It can be a separate tool. It just operates on the sources. Corsair is built in already. I use that for resolving binaries. S coverage, this is the same as warp remover really. Maybe there'll be built-in support so that it makes it easy to view your coverage, but certainly it's possible as a library. JMH support is built in with the benchmark module type. That's something I did quite recently. Scala.js, Scala native will both be built in. They're not there yet, but it's not too difficult to do. And publishing like SBT Sonatype will be part of the release architecture. What this means is that I can provide not just a solution that's been sort of forced into a limited plugin architecture. I can actually give a fully integrated user experience for all of these features. So this is a radical new tool which I'm proposing. It currently has lots of bugs. You can check the issue tracker and you'll see there's lots of things currently wrong with it. But I want to give you confidence in the tool. It will be supported by Propensive. That's Propensive the company, not so much Propensive me. I think a lot of people don't disambiguate between me and my company. The reason is that I'm the only person who works for the company. But we may grow over time. But I want to provide people with confidence. I'm competing with things like Bazel. There's a talk coming up next on Bazel, which has I think about 50 people at Google working on it. That's my competition. And Propensive, the company, is a small company. We run a conference. I say we. We run a conference in the UK and Scala World, and I run training courses across Europe. And most of the time, though, I'm spending time developing open source software. Incidentally, this one earns me money doing the training. I need that to keep eating and not getting rained on. I organise Scala World. That breaks even. It's not a loss-making conference, but it's not a profit-making conference. It's also a lot of fun. And developing open source software uses up all my money because I'm spending all my time not earning anything, but having lots of fun writing things like Fury. So they more or less break even, but I want to develop the company, develop it as a vehicle for promoting Fury, and I want to give you, as I said, confidence. It's a leap of faith to adopt a new tool, and although I'm registered in the UK and for various legal reasons now in Estonia as well, I think it's meant to be today we were meant to be leaving the EU, but that got cancelled or delayed, not cancelled. So I'm also registered in Estonia. But I've entered into a partnership with Virtus Lab, who are a Scala company based in Krakow. How many people here know Virtus Lab or know of Virtus Lab? Maybe about half of you. So Virtus is a very quickly growing company. They're actually in the top 1,000 fastest growing companies in Europe at the moment. They run a conference called Scalasphere, which is very worth going to. It's not that far to Krakow. They have a huge amount of experience of working with tooling, and they are supporting Fury, and they're supporting me in doing that. Virtus Lab are hiring, and they hire several people already from Ukraine. So if anybody is interested in joining a company that works with Scala, they're fully behind Scala as a language, and they provide me with 2 full-time engineers to work on Fury. So if you would like perhaps to have the opportunity to work on Fury and get paid for it, something which I don't get, you could get paid to work on Fury, then consider going to virtuslab.com and checking out their applications process. So because they've given me 2 full-time engineers, I've given them a to-do list. They're going to provide publishing on Maven Central, support for Windows. It's not a priority for me, but for many corporate users, that's important. Profiling and performance, this is one of their areas of expertise, which isn't really so much one of mine. Integration testing. The ability to export to SBT. this doesn't sound like a feature I want to be promoting. But I said, I want to give you confidence in the build tool. And when you're considering adopting something, the exit strategy is important if you need to use it. So I want to develop that feature so that you know if you want to, if it doesn't work out, then you can get out. You can export to SBT. That's a feature I hope we develop and never gets used. They're doing some bug fixing and also work on my other libraries, Magnolia, Contextual, Kaleidoscope, and about 20 others. On my to-do list, most of the features are implemented. There's a few more things that need to be finished, but I'm looking at code cleanup, support for Scala.js, Scala native. What is this? Kotlin. I realized that you could also support Kotlin as well. It takes sources, it takes a class path, it produces class files. What's not to like? It can run as a compiler in Fury as well. That's something that's maybe not so interesting to me from a language point of view, but is interesting to see if we can support that as well. Support for code coverage. You can see the list of issues on GitHub. And also, you may maybe notice this talk was called How I Converted the Typelevel Ecosystem. And I didn't do that, but I did include this bullet point that reminds me I need to do that at some point. Shapeless currently compiles with Fury and works pretty well. Am I running over time? This is the last slide. So the source code is now available online. It's been there for 4 or 5 months. I started work in December with Virtus Lab, and we've seen some benefits from that already. The first private beta came out at the start of this year, and I'm hoping that we can get version 1 out around the same time as Scala 2.13. Luckily, Scala 2.13 keeps getting delayed, which means that I don't feel so bad about it. That's all I've got. Thank you for listening. Do I have time for questions? I suspect not. Does anyone have questions? Yeah, if nobody stops me, I'll keep. Does any? You have a talk next, so it's only polite. I'll take one question. Yeah.
So you mentioned that in your to-do list you have a Kotlin support. Why not Java support?
Java support is already there. That's why. It was so easy I didn't even mention it. Okay. But yeah, great question. Can it build fat jars? Yes, it can. That's part of the release process. So when you release something, it knows that it needs to release all of the class files that aren't provided by the dependencies. So when you specify the release, if you can basically decide how to partition your graph. So you have the graph of dependencies, you have the binary dependencies on the outside. You can decide how to partition that. If you don't have any dependencies and you don't partition the graph, then it ends up being a fat jar with everything. If you partition it carefully into different modules, then when you release it, you'll get the different modules with the appropriate dependencies.